Hello, everyone, and welcome to this session. I'm representing ExcelR Solutions, and I would be discussing about probability distributions and a few of the preliminaries which are required to get a better understanding on the probability distributions. My name is Bharani Kumar. I have over 13 years of experience, and I've been into data analysis since quite some time. Majority of my career has been into this data analytics, analyzing the data, building the models for CMMI, so on and so forth, driving the Six Sigma projects and all that. Hope you would enjoy this session and find some meaningful output out of this session. All right, so here is the agenda. I've broken this agenda into two parts. I mean, earlier I was quite sure that I could complete all the probability distributions within time, within the given 1 hour duration, but then I thought that it would be difficult for me to cover all the concepts at one go. And if I were to cover all the concepts at one go, that means I should rush through the topics. I do not intend to do that. So I've divided it into two parts, part one and part two. Hopefully, we will be able to cover part one with ease, and part two we will look into when we can discuss that moving forward. Maybe sometime next week or the week following that, we can have another session. As part of part one, we are going to discuss about continuous and discrete data types. What is a random variable all about? What do we mean by probability? Then we'll discuss about probability distributions. And we would discuss about one another important concept called permutations and combinations, which is extremely important from the probability perspective. And then we'll discuss about the famous distribution called as normal distribution. And when do we call this normal distribution as standard normal distribution? And then we'll discuss about binomial distribution and finally hypergeometric distribution as part of today's session. Part 2 would include Poisson distribution, negative binomial distribution, geometric, log normal, exponential, Weibull, bivariate, binomial, and hypergeometric. This is what I intend to cover briefly as part of a session. All right, let us get started with the data types first. Primarily, we have two data types. One is continuous and another is discrete. Whatever be the data on the planet would fall into either of these categories. You either need to call a specific data as being continuous or discrete. When do you call it as continuous? If I can represent something in decimal format, I call it as continuous distribution. So, what does that mean? If I want to represent the weights of people, I can say a person weighs 85 kgs, or I can say a person weighs 85.7 kgs. If I can represent something in decimal format and if it still makes sense, it is continuous data. I can say my height is 6 feet, or if you want me to be precise, probably I'll say my height is 5.11 feet. The moment I represent in decimal format, it makes sense. That is continuous data. When you go to your fuel stations, price of 1 liter fuel would be petrol would be what? 69 rupees, 72 pies. Do you ever argue with them saying that, hey, 72 pies doesn't make sense? You never argue because money is continuous data and it can be represented in the decimal format. Time, cost, and your scale is normally continuous. All right. Now think about these. Laptop. I can either say I have one laptop or I can say I have two laptops. Can I say I have 1.5 laptops? Can I represent it in decimal format? What do you think? Can I represent number of laptops in decimal format? And does it make sense? I would request you all to use the chat window to answer. Absolutely no. Hence, it is called as discrete data. If I cannot represent something in decimal format, or even if I represent if it doesn't make sense, that is called as discrete data. Number of cars. I can say I have one car, I have two cars. Can I say I have 1.7 cars? Absolutely no. It doesn't make sense, right? If I ask you how many times your wife beats you, you can say your wife beats you once, twice, or thrice, but you can never say your wife beats you 3.5 times, right? So anything that cannot be represented in the decimal format is discrete data. Here is a question for you all. Distance traveled in kilometers. Is this continuous or discrete? Continuous, absolutely, you're right on that. If I ask you this question on number of houses you have, is this continuous or discrete? There we go. Yeah, so Nitin, on an average is different. A data or a variable as a standalone is different. Yeah. So to answer Nitin's question, Nitin says, but sometimes the statistics say there are, for example, 1.5 cars per person in the US. That is on an average. On an average makes sense, but as a standalone measure, number of cars, for that 1.5 doesn't make sense. All right. Let us move on and try to understand what is a random variable, because this is at the heart of each and every probability distribution. We might have heard umpteen number of times about random variable. But what is this all about? We will split this into two parts, random and variable, and then try to understand this. Here is a classic example of flipping a coin. Yeah, most married people play this game, right? Head, wife wins, tail, wife wins. All right. So, what are the two possibilities if I flip a coin? What are the two possibilities if I flip a coin? Head and a tail, absolutely. You can either get a head or you can get a tail. So the output, if I flip a coin once, the output varies. If I say the output varies, that is variable. If I roll a die once, die is singular, dice is plural, by the way. So I'm not rolling dice, I'm rolling a die. If I roll a die, what are the possible outcomes? What do you think would be the possible outcomes? Absolutely. I can either get 1 or 2 or a 3 or a 4 or a 5 or a 6. When I roll a die once, the event varies. I can either get a 1 or a 2 or a 3 or a 4 or a 5. So it varies, hence it's called as a variable. It varies. Then when is it called as random? It is called as random when you can associate a chance or a probability with an event occurring. Now here is my question. If I flip a coin once, what is the probability that I get a head? Absolutely, it is 1 by 2, right? So head is just one event out of two events. So the probability of getting a head is 1 by 2, which is nothing but 50%. What is the probability of getting a tail? If I flip a coin once, absolutely. Tail is just one event out of two events. Total number of events which are possible if I flip a coin is 2. Out of that, tail is just one event. So 1 by 2, which is equal to 50%. Now, what is a probability that I get a 1 if I roll a dice once, roll a die once, sorry. Absolutely, it is 1 by 6.
Muted.
1 by, oh, sorry.
Unmuted.
Sorry, I was on mute, my bad. Okay, it is 1 out of 6 possible events. So 1 by 6 is the probability of getting a 1. Now let me extend this question in asking on what is the probability associated with getting a 2 when I roll a die once. No, it's 1 by 6. One event out of total 6 events. The probability of getting a 3 is just one event out of total 6 events. Probability of getting a 4 is just one event out of total 6 events. So probability of getting any one number is 1 out of total number of events, which is 6. Since there is a probability associated with these events, we call it as random. And since the output varies, it's called as variable. Both put together, it's called as random variable. Random variables, take any statistics books or mathematics books of your choice. Random variable would be represented using capital letter, such as capital X or anything which is in capital letter. And this capital letter is called as random variable, which can take multiple inputs: x1, x2, x3, x4, so on and so forth. For example, the process of flipping a coin can be represented as a random variable, and within that you can have two inputs, x1 and x2. X1 is equal to head and x2 is equal to tail. Similarly, rolling a die can be called as a random variable which can take values 1 until 6. So x1 is 1, x2 is 2, x3 is 3, so on and so forth, as x6 is equal to 6. Remember this, because when you want to further enhance your knowledge, read any of the mathematical or statistical books. Random variable would be represented using a capital letter. It need not be X, it can be also a capital Y or a capital Z or a capital A, whatever be it. And the values which this capital letters can take are represented using small letters. This is one key thing that you need to remember. All right, let us move on. How many of you all play cards? This question is only to women because nowadays men stop playing and only women play, right? So what do you think? Or how many of you all play cards?
Unmuted.
Yep. How many of you all play cards? Did you guys hear me? How many of you play cards? None? All right, I think not many people want to open up. All right, that's okay. I'm assuming that you all don't know how to play cards, so let me explain. Playing cards, a deck of cards would contain 52 cards. A fair deck is what I'm speaking about. And it will have four variants. You will have club, you will have spade, you will have heart, and you will have diamond. All right. And A or ace is usually represented as 1. J is represented using 11, Q using 12, K using 13. All right. Now here is the question. Suppose you randomly pick a card from the card deck. If you randomly pick a card, what is the probability that this card will be bigger than 10? Can you all try to answer this? I'll help you all solve this. How many numbers would be greater than 10? We have three cards. We have a J, we have a Q, and we have a K. How many J do we have? We have four variants of J. J club, J spade, J heart, and J diamond. So we have 4J. How many variants of Q do we have? Four variants. How many variants of K do we have? Four variants. So the total possibilities would be 12 out of total 52 cards. And this is the probability of you getting a card which is bigger than 10. Now can you all try to calculate this? What is the probability that if I randomly pick a card from a card deck, the card would be bigger than or equal to 10? I'm parallelly looking at your chat messages. All right. So you can get a 10, J, Q, or a K. You have 10 variants of, you have four variants of 10, sorry. You have four variants of J.
Muted.
We have four
Unmuted.
variants of Q, and we have four variants of K. So in total, there are 16 cards out of 52 cards. Total number of cards of 52. This is a probability of you picking a card randomly, which happens to be bigger than or equal to 10. What is the probability that you get a card which is smaller than 3? So how many cards do we have which are smaller than 3? We have only two cards, right? You have A and you have 2. We have four variants of A and we have four variants of 2. So if I were to look into the probability of smaller than 3, it would be 8 out of total 52 cards. Absolutely. You all are getting it right. Now, what is the probability that if I randomly pick a card, it happens to be between 4 and 8, greater than 4 and less than 8? So how many values do we have? It can either be,
Muted. Unmuted.
sorry, it can either be a 5 or a 6 or a 7. We can have four variants of 5, four variants of 6, and four variants of 7. So if I add all of these, I would get 12. So there are 12 possibilities out of 52 cards if I randomly pick a card. Now, how can it be 3 by 13, friends? How can it be
Unmuted.
3 by 13? No. 5, 6, and 7, you need to look into. You having, if you look at 5 here, you have four variants of 5. If you look at 6, you have four variants of 6. And if you look at 7, you have 4 variants of 7, right? In that sense. Absolutely. Perfect. All right. Now, let me move on further. And let me try to quickly explain about multiplicative rule and addition rule. Multiplicative rule. If two events are independent events, that means if I toss a coin once, I can either get a head or a tail, but I cannot get two at one go. Hence, it is independent event. And the formula to calculate the probability of you getting a head and a tail would be a multiplication of these two, probability of A multiplied by probability of B. However, if there is any dependency between the events, you use this formula, which is probability of A multiplied by probability of B, given that A has already occurred. I'll speak more on this part here in conditional probability. Next, we have additive rule or addition rule. If two events are not mutually exclusive, what do we mean by mutually exclusive? You know about independent event, meaning getting one event doesn't have anything to do with another event. Mutually exclusive means if I roll the dice twice, right? I getting ahead in the first event has no influence on I getting ahead in the next event. Right? So I getting ahead in the first event has no influence on I getting ahead in the second event also. If I roll a coin twice, that is called as being mutually exclusive. If it is mutually exclusive, you can directly add the probabilities. And if they are not mutually exclusive, you add both the probabilities and subtract by probability of A and B. Now, the most important part is conditional probability, because most often than not, we tend to deal with this scenario. Probability of A occurring given that B has occurred. Probability of A given B is given using this formula. Let me give a real-time example here. Do you know what? Gmail has this option. I mean, everyone and anyone would be aware of this, right? Whenever you get new email into your Gmail inbox or mailbox rather, your Gmail would automatically segregate an email as being spam or not,
Did.
right?
Unmuted.
Whenever you receive a new email, your Gmail algorithm would look into that new email and classify the email as spam or not spam. And nowadays you have separate categories for classifying an email as promotional email or social email, etc. In this scenario also, if you want to calculate the probability of classifying an email as spam or not, given that it has the word lottery. Now, not all the emails which have the word lottery should be treated as spam. What if your organization sends you an email saying that, hey, if you receive an email with the subject lottery, please do not open that. That is a virus. If your organization is going to send you all such emails, should those emails also be sent to spam? Absolutely no. That's a warning message sent by your IT department. Why do you want to classify that as spam? Hence, not all emails having the word lottery should be classified as spam. However, if you want to calculate the probability of classifying an email which has the word lottery as spam, Then comes your conditional probability into picture. Probability of spam given lottery would be equal to what? Probability of spam and lottery divided by probability of spam. Right? This is called as your conditional probability, which will help you calculate and solve a lot of business scenarios. Please read this exercise and let me know what is the right answer to this. I will give you a quick 2 minutes to do so. The probability of both cards being aces, if you draw two cards from a deck and you're also following it up with a statement which says two events are dependent because you're not replacing the first ace into the deck before drawing the second ace. Probability of getting an ace for the first time is equal to 4 by 52 because you would have 4 aces out of total 52 cards. And are you replacing that first ace back into the card? You're not doing so, right? From 52, if I remove one card, I will have 51 cards, right? So the number of cards got reduced to 51. And what if the first card happens to be ace? Then the number of aces would get reduced to 3. So it'd be multiplied by 3 by 51. Perfect. Now let us understand what is probability distribution. This haunts us a lot, right? What is a distribution? What is a probability distribution? So on and so forth. So let us crack this. Say you have the daily sales of a large flat panel television set at a store X. Probability of selling 0 television sets is 0.40. Probability of selling
Unmuted.
sorry. Probability of selling one television set is 0.25. Probability of selling two television sets is 0.2. Probability of selling 3 is 0.05. And probability of selling 4 television sets is 0.1. If I can represent the events of selling the large flat panel television sets on the x-axis, and if I can represent the probability of these events occurring on the y-axis, then this is called as probability distribution. Simple. Event on the x-axis, probability on the y-axis. Look at this. Probability of selling 0 television sets is 0.4. So probability of selling 0 television sets is 0.4. I have a bar for that. Probability of selling one television set is 0.25. For one, I have 0.25. Probability of selling two television sets is 0.2. I have a bar for that. Probability of selling three television sets is 0.05. I have a bar for that. Probability of selling four television sets is 0.1, and I have a bar for that. If I can represent the event on x-axis and probability on the y-axis, probability of the event occurring on the y-axis, this is called as probability distribution. It is that simple. Now here we directly have the probability distribution table. Looking at this, let me know what is the probability of a sale. When do you say that a sale is happening? If you can sell more than one television set, right? So if you can sell one television set or two or three or four, any of these, it would be called as probability of selling something. So you simply need to add all of these values. 0.25 plus 0.2 plus 0.2 0.05 plus 0.1. In the summation would be 0.6. Perfect. It's 0.6. Now, what is the probability of selling at least 3 television sets? At least 3. Absolutely. At least 3 is greater than or equal to 3. Probability of selling 3 television sets is 0.05 and probability of selling 4 television sets is 0.1. Summation would be 0.15. That is a probability of selling at least 3 television sets. All right, let us move on and discuss more about this. Then, what is this discrete probability distribution? What do you mean by continuous probability distribution? It is very simple. If you're dealing with discrete data, it is called as discrete probability distribution. If you're dealing with the continuous data, it is called as continuous distribution. Now, what distribution is this? Is this discrete probability distribution or continuous probability distribution? What do you think this is? Absolutely, this is discrete probability distribution because selling the large flat panel television sets is discrete, right? I can sell either one television set or two or three or four. Can I ever sell 1.5 television sets? That would be a little trickier. Absolutely, Emma, you got it. Hence, this is discrete. All right. Now, another small concept of permutations and combinations, and then we will move on with the first probability distribution. The main difference between permutations and combinations is order or arrangement. Look at this. Combinations are used when order does not matter. When I say order, sequence, arrangement doesn't matter. For example, selecting 5 data scientists for a project who are all equally qualified. I mean, say you have 20 people in your project and you need to pick 5 people and assume that all 20 people are equally capable. Then whether you pick person 1 or person 5 or person 10 doesn't really matter because everyone is equally capable, right? Under such scenario, you have this formula called NCR. Now tell me, how do you write it? NCR. N is the total number of people. Since you have 20 people on your project, it will be 20 CR. R is the number of people that you want to select. So R represents the smaller subgroup and represents the larger group. This would be, 5. So 20 factorial by 5 factorial into 20 minus 5, which is 15 factorial. And I'm assuming you all know how to write this. 20 factorial can be written as 20 multiplied by 19 multiplied by 18 multiplied by 17 multiplied by 16 multiplied with 15 factorial. I'm not expanding further because I have 15 factorial on the denominator also. Probably I can get rid of these two. And 5 factorial can be written as 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. And then you do the normal calculation to arrive at the number of combinations that are possible to select 5 people out of 20 combinations. Yeah, Hema. Now, what do you mean by permutations? Permutations are used when order matters. Think about your ATM pin. What do you think will happen if you're going to enter the pin number in your own order? Right? If your pin number says it is 1416, Don't make a note of this. This is anyways not my pin numbers. 1416. You need to enter these numbers in this specific order only. Right? Otherwise, your card gets locked. Under such scenarios, you go with permutations when the order really matters. And when the order really doesn't matter, that is when you go with combinations. Here is an example exercise rather. Fruit is a salad. Sorry, fruits in a salad. Is it an example of permutations or combination? Number of fruits in a salad. Is it an example of permutation or combination? Combination, because you really don't worry about whether first fruit is apple, second is banana, third is orange.
Muted. Unmuted.
Okay. Whether the first fruit is apple or banana or orange, you really don't care about that. So it is an example of combination. Horse crossing a finish line in race. Is it an example of permutation or combination? Permutation, because first, second, third, fourth, fifth really matters in a race. Absolutely. Now, can you all answer this quickly? How many different A teams, appraisal team members? Since most of you all are from quality background, I thought of putting this example. How many different ATM teams of 5 members can be formed from 20 quality assurance team members? If you have 20 people in your quality department, how many 5-member ATM team can I form? Combination. Can you help me write that equation, please? Can you help me write the equation? If it's combination problem, what would it be? 20C5. So how would I expand it? 20 factorial by 5 factorial into 20 minus 5 factorial, which would be 15 factorial. Now, if you substitute this, I'm pretty sure it won't be 4. Combination. If it's permutation, probably you might be right, or maybe we need to calculate it further. But if it is combination, then the number would vary and you'll have a bigger number altogether. Let us proceed further to the first distribution, which is normal distribution. The best part about normal distribution is each and every normal distribution can be represented using mean mu and standard deviation sigma, right? When do you use these Greek letters? When we have population. See, we have a concept of population and sample. Elections in Assam, elections in West Bengal, etc. are about to close, and the news channels would very soon come up with their exit poll results. They would say which party would win, etc. Right? Obviously, they'll not go and check with each and every person in the population on whom they have voted for. Instead, they would pick a small sample and they would survey or do a telephonic questionnaire survey on this sample and then decide on which party would win. So when you work on sample, you denote mu and standard deviation using X bar and S. When you work on a
Muted. Unmuted.
sorry, when you work on a population, you denote it by mean mu and standard deviation sigma. So these are your population parameters. You always use Greek representation. Now, one more characteristic of your normal distribution, which is also called as Gaussian distribution, because a scientist by name Gaussian has come up with this distribution. This is always a bell-shaped curve. And what do you mean by it can be characterized by mean mu and standard deviation sigma? Let us understand it using graph. If you have mu equal to 0 and sigma equal to 1, assume that this is the shape of the curve or shape of the distribution. If I let my average remain as is, and if I reduce my standard deviation, what do you think will happen? What would happen if I reduce the spread, if I reduce the width? What do you think will happen? Absolutely, peak will increase, because think about a balloon. Say you have a balloon, you're trying to blow air into that, and then you press it on either side. That means you're reducing the width or variation of this. The moment you press, obviously because of pressure, it will become thinner, but your peak would increase, right? And that is what this concept is all about. If you let your average remain as is and reduce the standard deviation, this is how you can represent. If you let your mean remain as is and increase the standard deviation, you would have a wider peak. You're increasing the variation, right? Now, if I let my standard deviation remain as is and make mu equal to -1, what do you think will happen? Your entire curve, which is earlier blue color, which is earlier in blue color, would shift to the left direction. Now you have an orange color curve. If you let your standard deviation remain as is and change your average to +1, then you're shifting it towards the right direction, right? Towards the positive direction. Perfect. What does this mean? This means that if I know what is mu and what is sigma, I can come to know about the shape of the normal distribution. I can characterize any normal distribution using just two parameters, mu and sigma. This also has the following properties. So I'll give this example, which I most often than not in all the sessions give. International Cricket Council cricket ball. Whenever International Cricket Council wants some company to manufacture the cricket balls, they put some specification limits. Upper specification limit happens to be 229 mm and lower specification limit happens to be 224 mm. That means any cricket ball that is manufactured should fall within these limits. That is your specification limit provided to you by a customer. So let me put it down here. So your upper specification limit and lower specification limit. Upper specification limit happens to be 229 mm and lower specification limit happens to be 224 mm. If your process operates at ±1 sigma, then 68.26% of the observations would meet your requirements. That means if you're manufacturing 100 cricket balls, sorry, that means if you're manufacturing 100 cricket balls, approximately 68% of the cricket balls would meet your requirements. What if my process operates at ±2 sigma? to standard deviation. This means out of 100 cricket balls that are manufactured, approximately 95% of the cricket balls would meet the customer requirements. That is, 95% of the cricket balls, or to be precise, 95.44% of the cricket balls would fall within these specification limits. And if you operate at 3 sigma or 3 standard deviation, then approximately 99.73% of the cricket balls would meet the specification limits. Question to you all. I'm assuming that many of y'all are aware of what 6 sigma is all about. Is plus or minus 3 sigma on either side called as operating at 6 sigma? Or what do you think? Anyone? No, absolutely no, Ravi. Operating at plus or minus 3 sigma, or if you have 3 standard deviations on either side, it's called as a 3 sigma process. If you want to call a process at 6 sigma, then from the mean towards one side of the specification limit, there has to be 6 standard deviations. That is when you call a process at 6 sigma process. And the definition of 6 sigma is 3.4 defects per million opportunities. Think about this. I'll give you a small example on the difference between 3 sigma and 6 sigma. Though if you look from the percentage perspective, it is 99.73% if you operate at 3 sigma. And if you operate at 6 sigma, it is 99.999996. It goes on and on. From percentage perspective, you might feel that, hey, there is not a lot of difference. However, if you take example of an electricity company, electricity department firm, which generates power, if that industry or that particular plant operates at 3 sigma, then there won't be electricity for 7 hours every month. Can you think about what would happen if you operate at 6 sigma? You'd not have electricity for how many hours? Any guesses? Any guesses, friends? Uh-huh. Absolutely, a few of y'all are getting it right. You'll not have electricity for 1 hour every 34 years. Look at this massive, significant difference from a process which operates at 3 sigma to a process which operates at 6 sigma. A normal distribution is at the heart of statistics, is at the heart of 6 sigma, is at the heart of statistics, data analytics, building your PPM models, so on and so forth. Now, just give me one moment. Let me quickly check the time. So here are a few properties of your normal distribution. Normal distribution is always bell-shaped curve. You see this bell shape there? And normal random variable takes a value or any value from minus infinity to plus infinity. And
Did. Unmuted.
sorry, it is symmetric and centered around the mean, meaning the mean, median, and mode for a normal distribution will all be the same. That's another thing to remember. And finally, we know that we can characterize a normal distribution using just 2 parameters, mu and standard deviation. And you can write it in this way. X is a random variable. A random variable is approximately normal with mean mu and variance sigma square. Now I'll try to explain you all Why is it called as normal? Because there is no abnormality about it, right? So let me draw a curve, and there we go. So here, what is the probability that you find a person whose height is, say, 2 feet, a fully grown individual? It's very less, right? It's very less. And this line there extends until minus infinity to plus infinity. And if you want to find out the people whose height is 2.5 feet, 2.5 feet would be, I mean, finding those kind of people would be slightly more than finding a person whose height is 2 feet, a grown up individual. But still, it is negligible. Finding a person whose height is 3 feet would be slightly more than 2.5 feet, but still, it is negligible. Now, finding a person whose height is 4 feet is slightly more. Finding a person whose height is 5 feet is even more. 5.5 feet, 5.8 feet, 5.9, 6 feet. Yep. So majority of the people would have the height of 5 feet to 6 feet. Now, once again, if you start increasing the height of people, say you want to find out a person whose height is 6.5 feet, the probability of you finding that person would decrease. If you want to find a person whose height is 7 feet, probability would further decrease. And if you want to find a person whose height is 7.5 feet, it will once again become negligible.
Muted.
And
Unmuted.
there is nothing abnormal about this curve that I've drawn. And if I were to represent heights of people, this is exactly how it would appear. And one more small thing. Can I find a person whose height is 1 feet in this probability distribution? Because it extends from minus infinity to plus infinity. What do you think? Can I find a person whose height is 6 feet if this is your entire population of the planet? Anyone? Can I find a person whose height is 1 feet? Absolutely. Since this extends till minus infinity to plus infinity, we can. We can. This is the entire population of the planet that I've plotted here. Since it extends from minus infinity to plus infinity, it is entire population. And if you have the entire population, you can find all the people, absolutely. People with all the different heights in this. Be it 1 feet or 2 feet or 3 feet or 4 feet or 5 or 6 or 7 or 8. All of those would be found in this. So you can absolutely find every person in this. Person with all heights or people with all heights. Hence, the entire or the probability of this entire curve, which is called as area under this curve, is always equal to 1, because you can absolutely find everyone and anyone on this curve. All right. And one more last thing before we stop for the day and then proceed with the session later on is probability associated with a single value. If I ask you all on what will be the temperature tomorrow, and if one of you all would say that temperature in Hyderabad would be 46 degrees Celsius, then the probability associated with a single value is always 0, because temperature can be 45.8 also. Temperature can be 44.2 degrees Celsius also. Temperature can be more than this also. We cannot guarantee that the temperature would always be an exact number. Hence, hence, we always need to give a range. Think about your news channels or the newspapers. They always give a range, right? They always give a range. They say that the minimum temperature would be so much and the maximum temperature would be so much. Now, the probability of Tomorrow's temperature falling within this range is absolutely there. Okay, you'll have a probability associated with the values falling within this range.
Did.
I will take this
Unmuted.
final question and then we can stop. This question is coming in from Smitish. Is minus infinity to plus infinity applicable in all cases? No, I guess. In the height problem, we may not be finding less than 0.5 feet and greater than 9 feet humans. Yeah, I mean, realistically speaking, yes, Smitish. But if you were, if I were to believe that Gulliver Travels is true, and you have Lilliputians and the giants, then I would not agree with you. But otherwise, realistically speaking, yes. But that is the logic of normal distribution, that it extends from minus infinity to plus infinity, right? It might not be valid if we, get into the finer nuances, but yes, statistically it is possible. Yeah. All right, friends, thank you so much for attending the session. I would notify you on when we are going to have the next session, wherein we are going to discuss about the other probabilities starting from where we have left. Thank you so much for attending the session. Take care.